Hi guys, so today we'll be solving this problem called make lexicographically smallest array by swapping elements. Let's read it. You are given zero indexed array of positive integer nums and a positive integer limit. In one operation, you can choose any two indices I and j and swap nums of I and nums of j. If nums of I minus nums of j is less than equal to limit, return the lexicographically smallest array that can be obtained by performing the operation any number of times. An array A is lexicographically smaller than array B if in the first position where A and B differ, array A has an element that is less than the corresponding element in B. For example, the array 2, 10, 3 is lexicographically smaller than 10, 2, 3 because they differ at index 0 and 2 is less than 10, right? So we've been given this array. We are allowed to do a particular operation nums of I and nums of j swapping such that nums of I minus nums of j should be less than equal to limit, right? That is the condition. And we need to return the smallest lexicographically sorted array, right? The smallest array possible. So yeah, basically sorting it, but we have this constraint of nums of I minus nums of j should be less than equal to limit, then only we can sort it, right? So for this example, we have the answer as 1, 9, 2, 4, 6, 11, 14, right? So for this first example, we have this answer as the final output, right? Where what we have done, we've picked this, swapped it, and we've brought the lexicographically smallest array possible with nums of I and nums of j, there's subtraction between them less than equal to limit. And yeah, that is possible, right? So yeah, we like in this limit is probably, let's say it's 2, right? So yeah, if you do 1 and 6 swapping, right? Or like 6 and 11 swapping, right? It's not less than 2. So yeah, this is only the maximum possible, limit that we can do. The difference between nums of I and nums of j is less than equal to limit. This is the maximum possible elements and smallest array that we can create, right? So let's see how we can solve it. So what will be the approach to do it, right? So we have this constraint nums of I minus nums of j should be less than the limit, right? That is the idea. So what will be the approach to solve this? The idea would be pretty simple. So 15398. So what I'll do first, I'll sort this array, right? So let's take the first example itself. That would be clear. So 1, 11, 6, 2, 4, 9, 14, right? So sort it out. So when we sort it out, will be 1, 2, 4, then 6, 6, and then 9, and then 11 and 14, right? Okay, so we have sorted this out, and that's what we've got. Now, what we can do is, because we know that limit is 2, and the subtraction between any two element should be less than the limit, less than or equal to limit, so we'll group it. So now grouping. So, which means that we'll create groups if nums of I minus nums of j is less than equal to limit. So I'll just pick the subsequent or like adjacent elements right now. So 1 minus 2, right? 2 minus 4, right, is less than equal to limit. 4 minus 6 is less than equal to limit, right? So, and then 6 minus 9 is 3, which is not less than equal to limit, right? So that will go in another group. So 6, um, yeah. Then 9 minus 11 is less than equal to 2. But 11 minus 14 is not less than equal to 2. So 14 will be a different group, right? So once we have created groups, now we'll go back to the main array, right? So 1 is in which group? So 1 is here. So yeah, it's in this group, right? We remove this from that group and we go to the next element. 11 is which group? in this one group, right? In this group, 11 is there in this group. So we pick up 9 from there and actually add 9 here instead, right? Okay, 9 here. Then we go to the next one, 6. 6 in which group? In this group, right? So we remove this and we add 2 here, right? And then sorry, then we have 2. So 2 is in which group? It was in this group, right? So we remove that and add 4 here, right? Then 4 is in which group? 4 is in this one. Oh, yeah. 4 is in this one. So we remove it, add it here. 9 is in which group? 9 is in this group. Already we have removed this one. We have 11 left, so we'll add 11 here. 14 is in which group? Last group, so just 14 remains as it is, right? So we are updating this array. So because we have been given nums of I minus nums of j less than equal to limit, that operation can be done infinite number of times. I've created groups of it. So, right, in that group, I know that nums of I minus nums of j is less than equal to limit. I'm just going to use that whenever I see a operation, whenever I see an element from a particular group, and I just pick up the first element because yeah, we need to return the lexicographically smallest. So that's why, because each individual groups are already sorted among themselves and also following the nums of I minus nums of j operation, I'll just keep on picking elements from that group and replacing the current elements that I'm facing, right? So that is the idea. So let's get to the coding part in order to understand this a bit better. So let's get to the coding part. First of all, what I'll do is maintain nums sorted array, right? So nums dot begin to nums dot end and num sorted array, right? And I'll basically just sort it out from the end, right? So nums sorted, right? Once that's done, I'll just keep a current group equal to 0 and maintain that, and ordered map int comma int. I'm going to just have nums to group and maintain that, right? And nums to group will have pair of int comma int nums sorted of 0 and current group position. So this map will be kept to basically store all the elements and their current group assigned to it, right? And then eventually it will be added to the list, right? From there. And I'll also create a list here. Group to list, dot insert. What do we insert? Pair int list int, and here I will do current group and I'll also insert the list. So 1 comma nums sorted of 0, right? I'll add that at index, like basically the first position, right? Okay, once that's done, I'll just iterate through the nums size. So nums size I plus plus. In this, we'll be creating the list, right? So all the all the values which are obeying the nums of I minus nums of j less than equal to limit uh, condition, we'll keep them in one group and keep on separating on the basis of that condition, right? So if nums of I minus nums of okay, we are using the sorted array first, right? So nums of sorted I minus nums of sorted I minus 1 is greater than limit. If that's the condition, then I'll just do current group plus plus, and I'll just add the current element um, to the nums to group array. and I'll just assign the current group to it, right? And if one more thing, that we are not able to find the current group, sorry, is equal to group list dot end, which means that we need to create a new list, right? If that group is not already present. So group to, so this is group to list, right? So group group to list, not group list, group to list dot um insert. So at current group, I'll actually create an empty, right, list here. Okay. Once that's done, I'll have group to list dot at current group. I just need to push the current element, right? Okay. Once that's done, go down and I'll just need to iterate through the group, basically the list, right? So I'll first of all say that what is the nums of I, what and what is the group of that nums. So nums to group, I'll use that map to get the group of the current element. And once I get the group, it's simple. So whatever is element is at that particular group in the uh, group to list array. So I'll just use that, and also group to list array needs to have popped out the front element, and we need to return the nums in the end, right? That will update the nums, right? So that is the idea. Let's run it to see if everything is working fine. Okay, nums to group num, right? So that works. So that's submitted. I hope you guys understood the problem. Thank you so much.